Get my name up there, like all good students should do. So on this first problem, it says in the word wrestling, and I changed this to 9. 9 letters are chosen randomly. Solve the following probabilities. The first one says we want the probability that the first letter is a vowel and the last letter is a consonant. So we'll set this up. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, the first letter needs to be a vowel. How many vowels are there? We have 1, 2. So we have 2 choices that can go in the first position. How many consonants are there? There are 1, 2, 3, 4, 5, 6, 7 consonants. So I have 7 choices for my last letter to be a consonant. How many letters am I now left with? This is going to give me 7. How many letters can go in here? There's 6 left. How many in here? 5, 4, 3, 2, 1. Let's see. This is going to give me some nice number. Yeah. All right, when I multiplied this all together, it got me 70,560. But then since we want probability, denoted by the P, we want the probability, we're going to divide by the sample space, which is there was 9 letters, so we'll divide by 9 factorial. This is going to give me 19.44%. Okay? Again, the way we do percentages, if you see 0.1944444 going on forever, to do percentage, we multiply by 100. Multiplying by 100 moves the decimal place over 2, which gives you 19.44%. Okay, let's do the next one. B, we want the first letter as an S and the last letter as a consonant. So 1, 2, 3, 4, 5, 6, 7, 8, 9. How many S's are there? Well, there's only one. So there's only one way to put an S in right here. And then the last letter is a consonant. How many consonants are left? How many consonants have we not used? Well, 1, 2, 3, 4, 5, 6. There's 6. So I'm going to put 6 here. Now, I don't really care what other letters go in these other spots. So how many choices do I have left? I have 7, 6, 5, 4, 3, 2, 1. I'm going to multiply this together and divide by 9 factorial. This gives me 0.08333 going on forever. I'm going to then make this into 8.33%. Okay? And then lastly, this one we're looking for the probability, 1, 2, 3, 4, 5, 6, 7, 8, 9, that if I were to pull letters at random to make a word, or a 9-letter word, what's the probability that wrestling is actually going to get spelled? Well, if wrestling is going to get spelled, it's very set of how it's going to happen. There's only one choice for here. It has to be the W. There's one choice for here. It has to be the R. One choice for here. It has to be the E. This has to be the S. Has to be the T. Has to be the L. Has to be the I, N, and G. Okay, so if you multiply all this together, you're going to get 1 over 9 factorial, which gives you a very small number. It's 0.000. Hold on, I got to figure it out. Yeah, sorry, I had to check it on the calculator just to make sure. Yeah, so you get 0.000275%. So there's a very, very limited chance, in fact, nearly impossible, that you're going to get wrestling spelt, but it can still kind of happen. Okay, on the next one, this is 10 kids are stranded on an island, 7 girls and 3 boys, one of which is Alex Epstein. They managed to make a raft, but it's only big enough to carry 3 people, so they have to choose at random who gets to leave. Find the probability that the following gets to go. These are combinations. Okay, these up here are permutations. Okay, so 2 girls and 1 boy. Well, I have to say, how many girls are there? There are 7 girls, and I'm going to choose how many? It says to choose 2. I'm going to multiply this by how many boys are there? There are 3 boys, and how many am I going to choose? I'm going to choose 1. I'm going to divide by 10 my entire sample space. How many kids are there? And how many am I choosing for the raft? Choose 3. I'm going to set these all up first and then go back and do all the calculator stuff and give you guys answers, okay? If we want just the boys, that means how many boys are there? There are 3 boys, and how many of them are you going to choose? I'm going to choose 3 of them. So I still have to account for the girls, though. How many girls are there? There's 7. And how many am I going to choose? Well, there's going to be none. I'm going to choose none of them. And then I'm going to divide by the entire sample space. How many kids are there? There are 10. How many am I going to choose? I'm going to take 3 on the boat. Okay. The probability of at least 1 girl. This is the same as saying the probability of 1 minus the probability of no girls, which we just found up here. You could rewrite this as the probability of no girls. Okay, so with this answer, we're just going to say 1 minus this stuff right here. As for the Epstein question, you have to think, how many Alex Epsteins are there? Well, there's only 1. So we say there's 1 Alex, and we're going to choose him by saying there he is. So 1 choose 1 times everyone else that's going to come. So how many people are left after Alex gets chosen? There's still 9 kids left. I don't care if they're boys or girls. Just 2 of the 9 are going to come. So 9 choose 2, and I divide by my sample space, which is 10 choose 3. I'm going to do all the calculator work on this right now, and when the next slide pops up, you'll see all the answers. Okay, so here are our answers. We have 52%, or 52.5%. We have 0.833%. We have 99.17%. And here we have 30%. So there's a 30% chance that Alex Epstein's going to come on the boat. The next one is there a total of 720 permutations at a round table? How many people are there? Well, we had this formula that says n minus 1 factorial is how we solve circular permutations. And we got the answer of 720. So we have to ask, well, what factorial equals 720? Well, 6 factorial equals 720. So how did I get to 6 factorial? Well, it must have been 7 minus 1 factorial equals 720. Therefore, there must be 7. Okay, so again, there's 7 people, and that's because of our circular permutation formula, which says 7 minus 1 factorial equals 720. So this number here is how many people there must be. Here in 1855, city of Sevastopol suffered a siege. This happened in the Crimean War, if anybody cares. Crimean War. And I just asked you guys to set this up, all right? So how many letters are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's going to be 17 factorial on top, but then we have to divide by the repeating elements. So what repeating elements do we have? Well, S is a repeating element. How many times does S show up? It shows up 1, 2, 3 times. So we'll divide by 3 factorial. Well, what other repeated elements are there? I see 2 E's, 3 E's. So another 3 factorial to take care of the E's. Okay, and anything else? Yes, O's. O's are repeating also. So 1, 2, 3. 3 O's also, and 3 factorial. Okay, any more repeating elements? No, everything's looking good. So this will be the setup and answer for this problem. Okay, now for the back of the test. Right here we say that the probability of Mr. Wilson giving you an easy quest is 0.63. And yes, each test has an individual chance of having a 0.63 being easy, okay? But we want to apply this probability to the game of how many of the test out of 3. So this becomes probability of easy, so number of easy tests out of 3. And this has an equation that we have to follow that says NCX times the probability that it happens times the probability that it doesn't happen. Okay? So I'm just going to set these up, and then I'm going to magically the answers are going to show up. Okay? So P of 0 is going to be, let's see, 3 choose 0 times 0.63 to the 0 times 0.37 to the 3 minus 0, so 3. Okay? And then next is going to be probability of one test being easy, which is going to be 3 choose 1, 0.63 to the 1 times 0.37 squared. Then it's going to be P of 2, which is going to be 3C2 times 0.63 squared, because that's how many we want, times 0.37 to the first. And then lastly, we're going to get P of 3 equals 3 choose 3, 0.63 to the third times 0.37 to the 0th. I'm going to go ahead and grab a calculator and calculate these. They're just going to pop up. So the solutions we got is there's a point, excuse me, yeah, a point, excuse me, 0.5%. So sorry, there's a 5% chance of that none of the tests will be easy, 25% chance that one will be easy, 44% chance that 2 will be easy, and 25% chance that 3 will be easy. Okay, and a lot of you were able to do this or part of this, but then you didn't answer the question, because the question asked how many actually are going to be easy, in which you would need to have told me that 2 will most likely be easy. Okay, and we can visualize this by using the distribution curve. So 0 is going to be 0.05, so right about here. 1 was about 25%, so that's right about here. 2 was about 44%, so right about here. And then 3 was another 25%, so right about here. And then we have this distribution curve that looks like this. Okay, and that's what I was looking for as far as a curve was concerned. Okay, so the next set is exactly what we've been doing pretty much since the beginning of this. Okay, so the chance that both teams are going to win is going to be varsity wins and that junior varsity wins. Okay, I'm just going to set these up. I'll let you guys do the calculations to make sure they were correct. The probability that both teams lose is going to be the probability of varsity losing is 0.05 times probability that JV loses, which is 0.25. Okay, the probability that at least one team wins, well, this is 1 minus the probability that no team wins, or essentially 1 minus this answer right here, 1 minus, call this x, okay? And then exactly one team wins. The way exactly one team wins, I'm going to set up a Punnett square. Okay, so you have the probability of varsity winning and the probability of varsity losing, and then the probability of JV winning and the probability of JV losing. Okay, if exactly one team wins, there's 2 ways that can happen. It's either this square where varsity wins and JV loses, or this square where JV wins and varsity loses. Okay, what you do is you take these 2 probabilities and you're going to add them together. Okay, these are the only 2 ways that exactly one team will win. Is this situation, situation 1, or situation 2, okay? So to get the probabilities, we're going to add them together. Okay, and for the last question, this is a overlapping event, okay? So there is math techniques and then science techniques, and then we have to minus out the math and science techniques. So this is going to be 37 plus 29 minus 21, which is going to give you that you need to master 45 techniques. Okay, if there's any further questions on this, please stop me in class and ask me about it so that we can all score well on the very next or the last test. Okay, we'll see you all tomorrow.